He has delivered many public lectures on climate, water, and agricultural issues, and is regularly consulted by media for comment on tropical weather and climate events. I personally have seen him speak on television quite a few times. So let us welcome him.
Thank you very much. It's nice to have you all here. Thank you for coming. I recognize some faces, and you won't believe this, but my babysitter is here. And I'm not looking at you, Tony. Very welcome to her. And also some of my mentors, some of my teachers, some of those I've made friends with over the years, and I'm very glad to be here. So there are 3 lectures. The first one is on the science of climate change. The second one is on the mitigation, or how to prevent, or what we can do about climate change. And the third one is a bit of the sort of, well, just in case we can't do anything about it, what are we going to do in that event? So those are the 3 lectures. The question time today will be not long, but tomorrow and Wednesday there'll be more question time, because the presentation today is quite long, and I want you to go home and think about things and consult 2 of the websites that I'm going to give you. Firstly, how many of you did geography at school? Okay, how many of you didn't do geography at school? And how many of you don't put your hands up when someone asks you to? There's always one, and they're usually at the back. Great, and so some of you actually teach geography, so this picture is not new to you. Okay, I took this on one of my field trips recently. Cue laughter. But the interesting thing was, when I was up there, that I noticed that at night the borders of the countries glow. And that is because there's many armies that go around with fluorescent paint and actually paint those borders in. And you can see that at night. So obviously we have day, we have night. This is 7 days in the history of the planet. If you look very carefully, you will see that during those 7 days, nothing happened. Okay? Yes, of course, some things happened, because you can see 3 or 4 very, very important things there. First of all, when it's that color because of a very, very important scientific fact, and that is the presence of the sun. Okay, the sun shines on the earth reflects the sun, we see the colors. Those colors are not completely true to life, but they're good enough. The sun is the most important thing. Very important to remember that. The second thing we see there is the green and the brown. That's the continent. And the green obviously indicates vegetation, and the brown indicates a lack of vegetation or brown vegetation, and we can see that there are differences. And we know from geography that's because some places it rains, and some places it rains less. And some places it rains in one season, and other places it rains in another season. The third thing you can see there, well, you can't see it, is the oceans. But the oceans are not the continents. Okay, so they're very, very important. That's the sea, that's the moisture in our planet. And the fourth thing is a consequence of that, and that is the clouds. And it's very interesting. If you look at the equator, you can see the clouds moving towards the west. Remember, in meteorology, we talk of winds and directions a bit like nationalities. So if you're Mauritian, you're from Mauritius. If the wind is westerly, it's from the west. So you can see those winds blowing from the east, and then in the southern part of the country, or South Africa, you see winds blowing in the opposite direction. That is science. That is the geography. That is how the planet works. And we are going to ask ourselves, how is this changing? Or is it changing? And I promise you that in 100 years, the picture is going to look very similar to this. And some of you are already saying, but we know the climate has changed always. So we'll discuss those issues. What is the science behind the story? Well, this is a screenshot that I took yesterday just from recent climate change headlines, and you can see new climate regime, crop yields and reducing global food, climate apartheid, that's all about politics, climate change is making hurricanes more dangerous, climate change is devastating Central America, driving migrants, climate crisis. I haven't even got Australian fires. I haven't even got a picture of a polar bear on there. Because this is real news that affects people. Not that the fires don't, but there's some debate about what caused the fires and whether it's natural or non-natural. But it's absolutely clear that climate change is in the news. And it's my contention that this decade is going to be the decade where we sit up and take notice of climate change more than we have before. Now, many people say to me the reason they come to a talk is so that they can go to their mother-in-law, their grandmother, their grandchild, or speak to their wife, or anyone, or husband, or someone about what climate change is about. So I'm going to try and answer these questions. Is it real? How do we know it's real? Has it already started? What's going to happen? Can we stop it? And then what does it mean to me as a citizen of the world? What can I possibly do? And we'll be talking about these points over the next 3 days. Firstly, let me say to you, there are a lot of myths about climate. And these are understandable because we can't know everything about everything. But we must understand that there's only one way to find out what's really happening, and that is to investigate the science and the data. Data is information that we collect, that we gather, and we verify, and we use as a standard. Now, there are 3 cities there. Obviously, this is Cape Town, and that one you might not recognize because that building isn't there anymore, but that's, yes, anyone? 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 New York, thank you, and this one is either Hollywood or London. We're not quite sure, but let's go with London because it's wet. So the question is, which one of these cities has the highest annual rainfall as measured in the center of the city? Okay, so I hear people not even bothering to put up their hand, saying London, obviously. Second? New York, Cape Town, there's a bit of uncertainty. So let's look at the facts, all right? New York is 1,260 millimeters measured in Manhattan. Cape Town is 820 millimeters measured right there at Maltino Station in Oranjezicht, which represents basically the city bowl. And London, no, quick, grab your phone, Google, and I'll do it. There you go. That is London's annual rainfall. Now you see, you would not have thought that was possible. So there's a lot of stuff that we don't know. And we must interrogate. We mustn't listen to Fox News. Okay? We mustn't listen to what is trumpeted out there. We must be very careful to interrogate the science. Now, I don't believe in climate change. I think I'll go now. No, I don't believe in climate change. Me and Trump are like this. He doesn't believe, I don't believe. Trouble is, I don't believe because it's not a faith concept. I don't have to say, well, yes, I think I believe. I can't see, I can't hear, I can't touch, but I think I believe. No. I accept the scientific evidence that demonstrates that climate change is happening. I accept the evidence. So therefore you can say, I believe the evidence. And therefore I suppose you could say, I believe in climate change. But this is not a faith-based thing. And I've got nothing against faith-based religions or faith-based ideologies or anything like that. But climate change is not one of those. Okay, so don't believe in climate change, accept the evidence, and in that case you have to trust certain people who are providing you with that. And I hope that you'll be able to trust me. So the bottom line is that London gets less rainfall than Cape Town and New York. So why do we have water issues and not London? Now, that's something we can think about over the next 2 days. But one of the reasons is because our rain in Cape Town falls in winter, which is good, but when do we need it? In summer, which is bad. Because as you know what's happening now in summer, there's nary a cloud to be seen, and our dams are just getting lower and lower and lower. Because we use water, we need water, and we like water. I heard an interesting fact on Friday that parts of Holland last year got an average total for the year of 103 millimeters in Holland. So, be careful. Averages are not accurate. I look around this room and I'm thinking the average age here is probably about 38. Anyone here is 38. You see? So there's not a single soul here who's 38, and yet the average is 38. I mean, how does that work? So there's not a 1 year where London gets 583.6, I can promise you, and neither Cape Town 820, it all varies. So that's important to understand. When it comes to climate change, people always say it's the carbon dioxide. Now, carbon dioxide is a very interesting gas. You're all producing it right now, and I'm not being rude because it's part of life. The carbon cycle, if you did biology school, you understand the carbon cycle, and there are some images that relate to carbon dioxide exchanges. And it's very, very important to understand that carbon dioxide is part of what we call the life cycle, where carbon reacts with oxygen to form heat and carbon dioxide. And at this point, especially when I go to an old age home, I ask people to please just touch their necks there and feel if they are warm, because their breathing and their bodily function is going to produce heat. And if there is anyone who's not hot, then we need to call an ambulance. I'm sure it's not going to be a problem here. But that's the way it works. So in order for our bodies to get heat, in order for us to get heat, which is energy, which we can use, you could look at this equation and say, well, the byproduct is carbon dioxide. Well, where does the carbon come from? Well, the carbon comes out of the earth. The carbon comes out from organisms that have either decayed and formed coal and oil, or else it's live organisms like wood, like fruit, like vegetables, like food. Things like that. The greenhouse effect gets a bad rap. Now, if you're aware of what the greenhouse effect is or does, you realize that without the greenhouse effect, we'd be in trouble. The moon does not have a greenhouse effect. It doesn't have an atmosphere. Atmosphere and greenhouse effects are linked. The moon has no atmosphere. During the day, if you stand on the moon, you will get very, very hot, up to 60 degrees, 70 degrees Celsius, even higher, depending on the angle of the sun in your body. At night, you will get very, very cold, minus 35 degrees. The moon is not a good place to live. That's why there's nobody living there. But the Earth has got an atmosphere which is very useful, and we may have adapted to the atmosphere, or else it just was a big coincidence, or else it was designed that way. But the point is that inside our atmosphere, there are gases that absorb the heat that comes in from the sun, warms the Earth, and then warms the atmosphere. And that's very, very nice, because at night when the sun is switched off, for us, it's still fairly palatable. We can still survive. The temperature doesn't go to minus 30 because the atmosphere absorbs the heat. And there are a number of gases in the atmosphere, but the one that we're mostly concerned with is carbon dioxide, because that's the one that we have tracked that has been changing and has caused massive changes in the past. And we'll talk about that in a minute. So the greenhouse effect is good, but an enhanced greenhouse effect might not be good. So if the atmosphere is leading to an overall warming, that may have impacts that we haven't been expecting or not used to. So where does the increased carbon dioxide and methane levels come from? It's pretty much a third with each of these, roughly. And it also depends where you are. But electricity generation is a biggie. In this country, it's huge because we love coal. And coal is a very, very strong greenhouse gas emitter because we burn coal, which is almost pure carbon. You burn that carbon with oxygen, produces heat, drives our power stations, and the carbon dioxide goes into the atmosphere. That's the way we generate electricity. Other people may use gas, which is very similar, but it's more efficient. But when you get to renewables, it's a different story. Then they don't produce carbon dioxide, although there are small parts involved in the manufacture. Transport, because we use fossil fuels, transport is also a big emitter of carbon dioxide. Other gases as well, but mostly carbon dioxide. When it comes to agriculture, cattle, land, and forest clearing, it becomes a little murky because nothing's burning here. Well, forest clearing, a little bit of burning. But when you change fynbos into wheat, how are you possibly increasing emissions? How does a cow increase emissions? Now, a cow doesn't fart, excuse the language, greenhouse gases. Well, not much anyway. I mean, we all do that. It doesn't make a cow any different. The cow is different because the cow burps methane. Okay, now methane is a greenhouse gas that is much stronger at absorbing heat than carbon dioxide. I'll show you some figures in a minute. So that cow eats grass, which you and I cannot eat because we don't have the right stomach, and that stomach ruminates, and the cow has to chew the cud and burps up, and out comes the methane. So every cow is producing a lot of methane. So there's one of the answers. When we clear land and we replace fynbos, which is taking in carbon dioxide and releasing oxygen during daylight hours, 12 hours, but 7 days a week, 365, and then you take that out and you put wheat in, which is also green, which is also fantastic, but only for 2 months, a year, and it turns brown, then it doesn't take in any carbon dioxide. So effectively, you've increased the amount of carbon dioxide in the atmosphere by reducing the strength of that sink and by replacing forests, which are massive absorbers of carbon dioxide, you're doing the same thing. So this is not direct carbon dioxide, but by implication, it has its contribution. Now, not everybody has the same responsibility, or not everybody is equally guilty, if you like. So you can see the United States is massive according to the cumulative emissions. China is bigger, and I think this is 2000. China has got bigger. But certainly, look at South Africa in the African context. South America almost nil. Australia is pretty much a regular size. But you can see the Western Europe and the Northern Hemisphere are by far the biggest players. What about South Africa? Well, when we look at the carbon dioxide emissions, and this is per capita, per person, there's South Africa, and we're about 13th in the world. If only our cricket team could be that good. Okay, so we are players. We cannot point fingers at anybody and say, no, it's not us, because it is us. Sasol-2 is the single largest point source of carbon emissions on the planet. Okay, so we're leaders in the field, not something to be proud of. When it comes to Africa, there are a list of African countries, some very sort of poor and less developed, some oil countries, and you can see where's South Africa. Well, South Africa's off the scale. You know, we're up there somewhere. So we're the biggest player in Africa by far. And this is where our emissions come from. Energy, industry, transport account for over 80% of our emissions. So we are guilty. There's a nice picture of some solar things at the back, and we see these solar things and we feel wonderful. Not wonderful. Right, so greenhouse gases. There's a quick summary: carbon dioxide, methane, nitrous oxide, chlorofluorocarbons. They all have their contributions. And you can see if we rate carbon dioxide at 1 in greenhouse warming potential, methane is 21. Some of these other chemicals are much, much stronger. Now, they aren't very much. The volumes are very small. But we mustn't just focus on carbon dioxide, because this is where industry comes in. Okay, that's part of a very natural, if you like, natural cycle, methane too. These guys, not natural. Okay, they're human produced. So villain number 1 is carbon dioxide emissions, and you can see how the carbon dioxide has changed over the last 250 years. The secondary one is methane. You can see it's also increasing. And now we need to go back to that question, but hasn't the climate always changed? This is probably the most complicated graph you're going to see today, well, unless you're going to a talk later on this afternoon about nuclear power. The top graph, well, let's first look at the axes. That's carbon dioxide numbers, parts per million. That's methane, parts per million. That's temperature, degrees Celsius, not net, but measured at a reference point of 0 over there, and you can see it ranges across the ranges. This is 400,000 years before the present, and this is the present. Okay, so we are there now. These data are taken from ice cores in Antarctic, where we've got ice. It's around about 4.5 to 5 kilometers thick. Okay, this is from here to the power station, El Athlone power station. That's how thick that ice is. And by analyzing that ice, various analytical techniques and methods, we can determine what was in the atmosphere at the time that ice was formed, what was the temperature of the atmosphere, and within various error bars, we can draw these graphs. And nobody disagrees with these graphs. Okay, so it's not some climate scientist who got together and said, we're going to invent these. These are well established and well understood. So if we just look at the temperature, we can see that most of the time over the, let's just call it 500,000 years, the temperature has been a lot lower. If we look at us there now on 0, the temperature has been a lot lower. Now, how would the temperature get lower? And how would the temperature vary like this? So there are possibilities. The first possibility is what makes us warm in the first place? The sun. Well done. The sun makes us warm in the first place. So has the sun changed its hotness or temperature over the last 500,000 years? Very, very, very tiny. Hardly measurable. So that's a no. So you have to ask yourself, what could cause this? So we look at the other indicators and we see, well, carbon dioxide dropped, increases, dropped, increases, dropped, increases. So maybe the carbon dioxide caused the temperature. Well, hang on, why? Well, there was no women burning fossil fuels, not that we know of. And let's look very carefully, and we look here and we see, well, the timing not too clear. But you know, maybe one caused the other. And the secret is if you take later on this afternoon and you go to the fridge and you take out your tonic for your, gin, you would never have gin, none of you, New Year's resolution. You just take out your tonic water and you leave it on the counter, and when it gets warm, it gets flat. And what on earth has this got to do with this? Well, the oceans of the sea, which have absorbed carbon dioxide, when they get warm, they release more carbon dioxide into the atmosphere. That's the most likely explanation of this. And you can see methane is very similar, although it's a bit muted. So let's just focus on these two. We see that they are connected. The question is, what caused this? And the answer was synthesized by a Russian called Milankovitch, and he realized that the sun, the net effect of the sun on the Earth wasn't constant. And because the Earth has certain orbital features that take it a little bit further away, a little bit closer to the sun, over about a period of 120 years when these cycles then build on each other, we can see around about 120-year cycles between the maximum, which we see there, and the colder periods. And we call these colder periods ice ages. And what happened as the planet got cold, the ice caps expanded. As the ice caps expanded, they reflected more sunlight, and so there was a feedback. And the ice got bigger and bigger, and the Earth got cooler and cooler, and anyone who was living in the way of that ice had to then scarper towards the equator. Okay, and this is what happened over those years. And you can see that's a long period. I mean, it's not like the ice age arrived yesterday or the day after that. And we can see these various cycles of ice. Now, we have been out of an ice age, interglacial, if you like, these are called interglacials, for around about 17 to 20,000 years. We are expecting another ice age. Yeah, boo, global warming sucks. However, it may just be possible that our human-induced warming of our atmosphere is going to obviate or prevent us from going into another ice age, which would be very, very interesting. But the point is we should be going to an ice age. The other interesting thing about this period of 17,000 years is because we are now humanly developed and evolved, humans have developed language, they've developed all sorts of skills, they're mining and agriculture. And because agriculture now could be static and you could stay in one place and plant things, we now have what we would call civilizations that have situated themselves over the last, let's just say, 15,000 years in various parts of the world. So that's very interesting. The climate has always changed. Now, this is a very, very long period. Let's go to 1,000 years. We look at 1,000 years, and now we do kind of have people around, not walking around with fancy measurement instruments, but people who can record in books and say, oh, that lake froze over rather early this year, or that flower emerged, or that bird appeared, or that lake was low or higher or silted or less silted. And we can go into those records and we can look at pollen samples, we can look at sediments, and we can look at things, and we can actually now, within a degree of error, plot what the temperature was over the last 1,000 years. And you can see that, generally speaking, the temperature was kind of going a bit down, not by much. And then in the last 150 years, and this is kind of artificially colored, because up to the dotted line over there, you would have said, oh, there's nothing unusual about that. But what was unusual was that things are getting out of that envelope of variation. And in 1998, everyone, and John, you'll back me up on this, got a moerse skrik, which is Afrikaans for we're all going to die. Because not only was the temperature so incredibly different and so incredibly hot compared to the last 1,000 years, but also people thought, well, what is happening here? What is happening here? What is so special about 1998? Now, it happened to be an El Nino year, which means that the oceans released a large amount of heat. But it was probably the most important event that woke us up to the fact that global warming was going to be more serious than most people had thought. Let's look at the last 150 years. Here you see nothing special. Move along, folks. Move along, folks. General variation, nothing special. Until you get mathematical about it. And when you get mathematical about it, you start drawing lines. And if you go from 1900 to the year 2000, your line looks like that. I'm afraid it does. It just does. Okay, and you can work out whether it's statistically significant or not. But if you look at the last 50 years, you see, but hang on, that line is even steeper. And there seem to be changes happening. And then a skeptic comes along and says, hold the phone, Just keep your hair on. If you start at 1998 and you look at those 7 years or 8 years after that, we're going down. The whole problem's over. No problem. Problem solved. And we turn around, and any good maths teacher will say, you can't draw a graph with 5 or 6 values when you've got a history of a lot more. So then we get a little more technical, and we say, okay, let's look at the last 50 years more closely. And you'll see we've shaded out the ones that were El Nino years. In other words, the ones that were probably artificially hot. And you can see there's still the same pattern. There's 2016, a big El Nino year. We had a massive drought in this country. 2018 is there, and 2019 is there. So 2017 is still the highest. But the warmest 12 years we've had have all been since 1998. So something is going on. That's what's going on. Carbon dioxide emissions have been increasing every single year. There's a small seasonal variation due to vegetation in the northern hemisphere, which is where most of the land mass is. When the trees lose their leaves, there's less carbon dioxide being absorbed, so there's a peak. But carbon dioxide goes up every year. And why? It's not because the temperature is going up. It's because we are releasing carbon dioxide into the atmosphere. Well, that was the theory. But theories have to be proved. So we got together some scientists, just a few thousand, intergovernmental panel on climate change. Intergovernmental. Now, if you know government like I know government, they don't do things quickly. And they don't do things if they're going to threaten their existence. And this was a miracle, in my view, that this actually happened. Coordinated collection of scientific research reviewed and approved by governments. They looked at the science, the mitigation and adaptation, and they also issued special reports, specifically a very interesting one that came out last year. And these IPCC meetings happen every year. And you may have heard of Conference of Parties, which is the signatories to the United Nations Framework Convention on Climate Change, which is an organization of the scientists that work for the IPCC, and governments come along to the Conference of Parties, and they participate and they try and draw up certain agreements. We won't discuss that right now. But there's also the NIPCC, which isn't a real organization, but it's basically those people who say the IPCC is a load of codswallop. There's a word you haven't heard in a while. IPC is International Panel on Climate Change, actually Intergovernmental Panel on Climate Change. At this point, when it was formed, 831 qualified independent scientists publishing peer-reviewed research. Climate change is caused by us will be bad. These guys started off with 35 people paid by the fossil fuel industry. This is like smoking doesn't cause cancer, people. You know, to say whatever they think will cause doubt and inaction. Climate change is a myth. That sounds just like the Big Don. Look, there's a penguin. Misinformation. So what did the fifth assessment, 2015, I think it came out? Carbon dioxide levels are very likely. Now, when governments get together and oil-producing countries are in the room and you say climate change is real and it's guaranteed, they said, We found one scientist among the 15,000 who said, they're not sure. So you can't say definitely. So they worked out this language, but very likely is over 95% chance. The results of anthropogenic, that means us, we caused it, emissions. Temperatures are very likely to increase between 1.4 and 5.8 degrees by 2100. Sea levels are very likely to rise by between 0.1 and 0.9 of a meter. Okay, that's not much at all. We'll talk about that, what not much sea level rise means. And extreme events are very likely to increase. Now, the interesting thing about extreme events is we are experiencing so many more right now. But we don't know whether it's because of cell phones or because of climate change. How do cell phones change the weather? Well, it's unbelievable. You get tornadoes all over the country now. When we only used to get them in Rudaport. Why do we get them all over the country? Because people can tell us that they saw a tornado. Because before they saw a tornado, I thought, whew, there's a tornado. And nobody knew. Now we need, the notification of these events is so much more popular. All right, so there's a lot of text. Bottom line. Very high confidence that the globally averaged net effect of human activities since 1750 has been one of, you could have just said war. That would have also been valid. although there have been wars for a long time. But it's warming. Warming is what's the net result of human activities in the Industrial Revolution and the Industrial Era has been one of warming. We are heating the planet. The impacts are wide and many, and there are certain assessments: warmer and fewer cold days, warmer and more frequent hot days, heat waves, heavy precipitation events, increases in intensity and duration of drought. And if it's red, it's very, very important. If it's orange, it's very likely. And you can see the later on we get in the 21st century, the more likely these things are going to happen. But those are the sort of things that happen. Now, some people have said, and I even read a letter from somebody, and I don't know if that person is here today, but this person would say, clearly it's the sun. It's nothing to do with humans. Carbon dioxide is natural. We're in a carbon dioxide drought. It's the sun. Where's the evidence? Here's the evidence. These are sun activity, solar irradiation over the last 150 years. That's the temperature. If you find a connection there, please let us know. Because we don't see that. We don't see a direct connection between the sun and the increased temperatures. All right, so the IPC is a bit like this. 1990, this climate change thing is a problem. Climate change is definitely a problem. Yep, we should be getting on with this, sorting this out pretty soon. Look, sorry to sound like a broken. Hello? Is anybody listening? Is this thing on? Where are the governments? Scott Morrison says these fires have nothing to do with climate change. Hello? And it's really frustrating. Really frustrating. So the bottom line, say to the computer scientists, say to the modelers, can you find out any way that this is a natural event? So they put together all the solar events, all the volcanoes, all the heat waves, all the eclipses, what else do people say? Aliens, anything you like. Put it together. And then run the computer models and say where our temperature should have been by the year 2000 compared to 1900. And they all say, well, there were variations, but you pretty much should have been about the same. We said, but we're there. And they said, well, it's not our fault. You told us to exclude all human-produced emissions. So we said, okay, put them in. All right, case closed. We don't have a lot of time to spend debating about this. We've got to get on with our business. I'll be telling you a little bit about what to do in a debate, but we need to get on with our business. 2,500 scientists say we've caused global warming. I'd like a second opinion. Widespread changes in extreme temperatures, frequency of heavy precipitation events. It's likely that future tropical cyclones will become more intense. This is scary stuff. This is not just affecting Yanni Opse Plus. Okay, this is affecting millions of people. This is what's happened to the temperature in the last 100 years. If it's red, it's got hotter. If it's blue, it's got cooler. Oops. And the only reason it's got cooler there is a piece of ice broke off and melted. Okay, look at those temperatures. 4, 5 degrees over the last century. And this is the sort of temperature change that we experienced between 1921 and 69, which is 78 years, and 48 years. And you can see this thing is getting more and more rapid. Now, we're not 100% sure that that increased rate is because of carbon dioxide, because we fear and we think that there are feedback mechanisms. We all know that the permafrost contains a lot of methane, and if the permafrost melts, that methane is released instead of being trapped. That's not human-induced. That's not someone who went out there and caused it. It's a feedback. So those things we also don't understand completely, and the other things we don't understand. But in 2019, we hit some records. 120,000 US weather records were broken in 2019. And that's just an arbitrary number of weather stations that they recorded. But these are the things that happened. And look at this. This is all 2019. Paris, Netherlands, Germany, Belgium, Vietnam, Israel, Arctic, Alaska, Australia. Hottest ever. And in South Africa, not in 2019, but read this one very, very carefully. 2015, and it almost happened the other day, but it was a misreading of an instrument up in Vielsdorf. Was it Vielsdorf? Yeah, Vielsdorf. No ways. The Earth's hottest temperature ever recorded, but hang on, it says 48. But we know Death Valley gets to 52 and Libya gets to 56. Well, let's read the whole thing. Earth's hottest temperature ever recorded in the month of October. Oh, well, October. Well, that's not... Hang on. October's spring. It's not supposed to be hot in October. 48 degrees in October. Well, it was the hottest anywhere in the world ever recorded in October. Anywhere, including Libya, Death Valley, Arizona, Sahara Desert, and Fredendal, just up the road here. Just up the road here. Well, 250 k's, but close enough. Right? And that same day, these are the records that were broken. These are the stations just in the Western Northern Cape. Now, some of them, you might say, oh, well, look, it was 39.640. Hang on a second. 3 degrees. This one's 4 degrees. 4 degrees hotter than the previous hot one. So this is clearly something that's affecting us. And the question is, what are we going to do about it? And the question is, how is it going to affect us? This is the ice sheet. Oops, sorry. Okay, that animation is not working. That's odd. Anyway, the ice extent, you can see it's shrinking. The Arctic ice extent. Now, please remember that this is not going to cause sea level rise. Because we go back to your gin and tonic that you can have tonight. When you put the ice in that glass, the level goes up, level goes up. You put the ice in. Watch that level. If you can hold yourself, hold back. Watch until the ice melts. That level will stay the same. It will not increase as the ice melts. Arctic ice is floating. This is not causing sea level rise. What is it causing? Well, that's interesting. Well, if the Arctic ice is melting and it's not causing sea level rise, who cares? Well, polar bears for one, but let's not go there because that's a bit of emotional. Claptrap, my teacher used to say. Who cares if the Arctic Ocean cools or the Arctic ice melts? Well, Americans care and the Russians care because that water now gets much, much colder. And if the water gets colder, the air gets colder. And if there's a greater pool of cold air, you can be sure that they're going to have winter storms like they've never had before. And what is America having? Winter storms that they've never had before. And Donald Trump says, what? We could do with a little bit of global warming now. Okay, that sounds like Auntie Merle, but never mind. When we look at sea level rise, guys, it's not that impressive. It's not that impressive. We're really looking at millimeters, centimeters, maybe a meter. Now, if the sea level at Muizenberg rises by a meter, don't go living in Plumstead. Okay, because one big wave could arrive at your doorstep. Because the Cape Flats is what they say. It's flat. And if we look at a place like Bangladesh, 1.5 meter sea level rise takes out the whole coastal area. Okay, 22,000 kilometers, 17 million people affected. Now that is not even including Pacific Islands. Okay? If the Greenland ice sheet and the West Arctic ice sheet, which are both showing alarming signs of thinning, either, if melted completely, contains enough ice to raise sea level by 7 meters. But wait, I thought you said that floating ice doesn't cause... Well, it's not floating ice. It's ice on top of the land. If you take another ice cube off the edge of your glass and you put it in your gin and tonic, then that glass will overflow. So this ice is on land. Greenland, it's Greenland. The ice is sitting on top, and if that ice melts and slips into the sea, 7 meters each, 14 meters, not to be messed with. Is it going to happen tomorrow? No. When is it going to happen? We don't know. Depends on those rates of melting. But within the range of several climate projections for the 21st century. I'm not saying it is, and many people, well, very few people will actually go on record and say it's going to happen soon. But it can. But we don't need 15 meters. These guys had a cabinet meeting underwater. Okay? In the Maldives. They haven't bought land in India just in case they will have to evacuate the island. Who do they blame? Who's going to come and fish them out of their situation? It's a good question. Then we need to talk about the thermohaline circulation. We're getting deep into science here. This is underwater moving of water. Water currents that are moving. And this is the most interesting one, where you get this Atlantic Ocean drift, this drift that goes up into North America and Northern Europe, and then moves the North Atlantic drift. It takes warm water that keeps places like London the same temperature as New York. And there's about 10, 12, 15 degree difference in latitude. This circulation keeps Northern Europe alive. Okay, if this then shuts down because cold ice over there is melted and prevents this warm water from moving around there, this thing can shut down. Never mind about the other ones, just this one. It will close down Northern Europe. That is a problem. Is it going to happen? We don't know. Very difficult to measure this. If it does happen, you could have a scenario like this. Some of you may have seen the movie. Did you see the movie? I think it was called Wednesday. Anyone see the movie? Wait, it was called Day After Tomorrow. Wednesday, same thing. Interesting movie. So, what do we think is going to happen? Well, the scientists have got together to make projections, and they've said, well, we can't just make one projection. We've got to have scenarios. What if we don't produce so much carbon dioxide? What if we don't do this? What if we do? So they made what we call representative concentration pathways, and they divided them into numbers that's quite low and that's quite high, and those are the kind of cumulative emissions. Now, we're already over 400 parts per million, so you can forget about RCP 2.6, take it away, get the typics out, rub it out, because that would have taken us to a pretty nice situation by the end of the century. But that's not going to happen. This is where we are right now, RCP 8.5, heading towards 1,600 parts per million. Because why? Because for the last 10 years we've been saying to the South African government, you've got to get off coal, and the South African government says, oh yeah, about that. We put it on the agenda. We're not getting off any coal, not fast. And this is where we are headed. There's the trajectory. This is where we're going. So that means around 4 degrees by the end of the century. Give or take a couple of degrees either way, which is quite scary. But now who does these models? Whose thumb is it sucked out of, actually? Well, this is the story. In the mid-1970s, we worked out carbon dioxide, rain, sun. There was a connection. Interesting. Then we worked out, well, clouds have got a connection, and so is the land surface, and so is ice. And then the fourth ocean, we reckoned, actually, the sea's quite deep, so maybe there's a bigger effect of the sea. And then we thought, well, hang on, there's volcanic activity and sulfates and all sorts of things, and there's a carbon cycle, and things have got complicated. Now there's chemistry in the atmosphere, ozone layers, and all sorts of things. These things are not child's play. All sorts of things you have to take into account, and the scientists are doing it. They're doing their homework. They are not just sitting there thinking, how can we get funding? Look at that. That's the latest. There's a lot of stuff to take into account. Well, geez, I'm not even going to go there, but I mean, analyze that. This is important stuff, and the scientists are working very, very hard on that. So there are a few things we can say quite confidently. I need to move along. I think I didn't even set my timer. What are we doing? Yeah. I'm supposed to end at 1:45, am I? That's not going to happen. All right, so COP or no COP, we're committed to significant change. We've got unprecedented events are increasing. Regional changes will vary significantly. Changes in the behavior of the atmosphere are as important as changes in the average. In fact, even more important. Our average rainfall in Cape Town, we cannot, for the life of us, find a trend over the last 100 years. No, cannot find a significant trend. But I'm going to bring this into some of the slides during the week. But we have seen that in the last 30 years, more years are below normal than above normal. So we've got to do two things. One is face facts and say that's going to happen, or that's probably likely for the future, or else we have to say, well, hang on, we need to recalibrate. Okay, because maybe we are just getting into a slightly drier period and we have to move that down. Maybe it's not 820 anymore, maybe it's 800. But the behavior of our weather is very, very interesting. Globally, high latitudes warming greater, continental interiors warm more, global increase in precipitation. Interesting. Yeah, because not the whole world isn't all Mediterranean region. Okay, there they're getting thunderclouds, and thunderclouds are formed by heat. And evaporated water from the oceans feed those clouds. It's not what happens here. We get a slightly different system where we talk about high pressures and low pressures and cold fronts and things. Change can occur without the average changing. We've said that intensity of weather events, including hurricanes, is likely to increase. Little can be done to mitigate or prevent this from continuing until 2050, because it's a bit like that oil tanker. We stop everything now, it still carries on. The carbon dioxide is still sitting in the atmosphere. Feedbacks and thresholds increase the risk. Regional change is coupled to non-local events. That means that what happens in the Maldives isn't connected to the people of the Maldives. It's connected to global emissions, and that's quite scary. Africa, warm somewhat more than global. Drier subtropical regions warm more than the tropics. Africa rainfall likely to decrease in much of North Africa and Northern Sahara. Uncertain about the Sahel. I read a paper the other day that said the whole Sahel is beautiful now. Remember, the Sahel is where we had massive droughts in the 70s and 80s. The Sahel is looking good. It's a cycle. We're not sure how the Sahel develops. We are prepared to admit that we do not know everything about rainfall. Increases are likely in tropical and East Africa. They've just had floods. Winter rainfall is very likely to decrease in much of West and Southern Africa. That is what our models are saying. There's also increased drought. I'm not going to spend a long time on that, but we're seeing more and more droughts happening across Africa, more frequent. And we at CSAG have jumped in and said, right, we're going to try and downscale these changes. We're going to try and control the global changes just, or make them valid just for South Africa. So we use secret scientific code that I can't, okay, I'll tell you just this once, but please don't tell anyone. So this scenario is for DJF, which is December, January, February. Okay, and this one therefore is? Okay, you've got it, right? Now you know. So that's summer, that's winter. Basically, we're going to get hotter. And this is by mid-century. This is soon. This is relative to the year 2000. So we're looking at around about 2.5 degrees in the interior. And let me tell you, I know people living there. And they will say to you, what do they say exactly? Let me just say, verschrikkelijk warm. Okay, they didn't say that, but that's also Afrikaans for we're all going to die. When it comes to rainfall, these were our first projections in around 2005. This is what the model said, and this is the summer rainfall, and you can see the eastern part of the country increase in millimeters per month. Western, a little bit less, and then in winter we see a drying here and marginal wetting there. And then we sat and we thought about that, and we said, you know, we can't be sure about that. Even if that's the average of the models, we can't be sure. Just because everybody says something's right doesn't make it right. So you won't find that anywhere. We've taken that away. And what we have done is created now what we call a range of options. Okay, now the text is missing here, but this is, there it is, DJF, JJA, and our new friends MAM and SON. So summer, autumn, winter, spring. All the wet models, the top 90th percentile, which means the guys who really did well in wetness, the guys who did really well in dryness, and then the average. And then we'll see, okay, how does this look? Well, if we look at the Western Cape, the variation in summer is between 15 millimeters per month less to around about 5 millimeters a month more. Okay, we'll forget that. We don't get rainfall in summer. Well, not usually. Let's look here, because this is autumn. And when does it rain? When does the rain start in Cape Town? Easter weekend. We all know that. Easter weekend, yeah. Never mind, the Easter weekend varies in about 6 weeks from year to year. But it's always going to rain at Easter. The last 7 Easters haven't rained. But we know that's the cutoff. It is going to rain after Easter. So we look here and we see, hang on a second. The dry scenario, minus 30 millimeters a month. Well, hang on a second, we only get 30 millimeters a month in March. Well, that's scary. To around about plus 5. These are the ranges. Midwinter, right, here we're talking Turkey. Oh, shucks. Minus 35. Well, maybe we might get a little bit more. And then in spring, okay, which is what sometimes people say the seasons are pushing back, we're getting more rainfall in spring. You can see actually the increase is higher than the possible decrease. So that's the variation. What are the averages saying? Well, dry, 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 which is Afrikaans for turn, which is ironic when you talk about carbon emissions. But dry, 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 dry. That's the average. So we said don't believe the average. But if you were a betting person, you'd be buying rainwater tanks. Potential shifts in vegetation biomes. Scientists that are far smarter than any of us sitting here have worked out with all the sort of emission possibilities how the biomes, the different vegetation types are going to shift. That's important for natural vegetation and our natural ecology, but also for agriculture. Other impacts we can relate to, increase in fires. Electricity demand. We're going to need more electricity, not less. Deciduous fruit regions may disappear from the Western Cape. That's not good. I know apple farmers who are moving their apples, planting plums. planting other stuff, because apples need chill units, which is hours and days below a certain temperature, and they're not getting them anymore. Water shortages, shifts in growing seasons of crops, biodiversity threats, extinctions, market and product implications. What happens if we can't get our apples to Europe in time? And suddenly the Australians beat us to it. Well, let me tell you, the Australians aren't growing many apples either. My brother-in-law owns a cold storage plant for apples. It's empty. He's storing wine in there now, in Australia. Health issues, heat stress, disease spread. We've heard about Lyme disease, we've heard about malaria, we've heard about people dying of exposure to heat. It's a problem. All right, so what are we going to do, or so what? Quick lead into what we're going to talk about tomorrow. We've detected, we've predicted, we know there's uncertainty, but the next step is policy, behavior, and technology. How are we doing on that? Well, we've got some policies. Behavior, not really. Well, some of us, well, maybe not. First, we have to acknowledge that it's a problem. Let me change our behavior. Technology, yikes, there's not a lot. Well, there's all the renewables in the world. Okay, we've got problems with those, and someone's going to mention nuclear, and I'm going to say nuclear is not off the table, but we have to consider the full cost of nuclear and very, very cautiously venture into that. But adaptation, that's what we'll be talking about on Wednesday. Stern Review was an economic outlook about what's going on. Essentially, what it says is climate change is an urgent issue. If we weight the costs of climate change as well as the costs of mitigating, the longer we wait, the higher the costs will be. Doing nothing is expensive, and it's going to be expensive. And then there are certain ecologists that have said, right, guys, the 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, absolute total disaster. Okay, let's try and hold it back at 1.5, and that's what you've heard people doing. The chances of that are very, very small. Extreme weather events, risks. Some things we don't know about. What are the true benefits of a global consensus on climate change? Well, it seems like if he's not going to do it, we're not going to do it. If they're not going to do it, we're not going to do it. And that seems to be the consensus. Is there any benefit in consensus? We're not sure. Feedback mechanisms, I've spoken about that. Crossing thresholds, the thermohaline circulation, ice sheet instability, methane release from permafrost. These things we cannot predict. And they can bring calamitous results. Acceleration of change is likely. Unknown couplings. If the Arctic melts, and they're already exploring now, the Russians want to explore and the Americans want to explore in the Arctic Circle. The traders in their tankers and their trade ships are saying, woohoo, we can now go from London to Beijing without going past Cape Town. Let's go over the North Pole. Easy schmeezy. What's going to happen to our economy? Well, we don't know. How many ships come past every day? I don't know. It's uncertain. We don't know about those things. How are we prioritizing climate science and climate research? In South Africa, CSAG is well known to be leaders. In Africa, CSAG is well known to be leaders. In the world, CSAG is well known. Okay, we are recognized, and I think the government is supporting us. The Western Cape government is obviously supporting us. But when I go and visit other provinces that have climate change, I don't think our government is doing anything. Well, not much. Yeah, water is an issue of concern. I'll talk about that. So, before I finish, and I think my time is always up, I'm going to ask you, can you defend the arguments? Now, I haven't mentioned all of these, but let's run through a few of them. For thousands of years, the Earth has gone through normal cycles of temperature change. We are simply in a warming cycle, right? We know that's not true. In earlier eras, there have been far higher carbon dioxide concentrations in the Earth's atmosphere than today. How do we know are human-inflicted and not natural? Well, we have to interrogate that. We have to look and see what caused those. We have to see what the connection is to temperature. Volcanoes, dying vegetations produce far more carbon dioxide. When last did you see a volcano? Okay, well, you probably saw it on TV. There was that famous one that no one could pronounce. Probably also just meant in Icelandic that we're all going to die. But a volcano doesn't produce a lot of carbon dioxide. It produces a lot of sulfur dioxide and a lot of soot. There is carbon dioxide. And that soot, in fact, has a cooling impact to some degree, but then it's black soot, so it absorbs more heat. So it cools, but it heats, it's complicated. They did work out, though, that the negative effect of that 7 days of volcano was equivalent to 1 day's emissions of the country of Belgium. So don't get excited about that. Right, so carbon dioxide is a naturally occurring compound. CO2 means more plant growth. More carbon dioxide is good. And we know that carbon dioxide can be used to fertilize plants. We know that certain crops, C4 grains, they love carbon dioxide. And they will produce a higher yield to a point when suddenly the temperature